Alright guys, so this is the basic refrigeration cycle. We're going to start with the compressor. At the top there you see the compressor compresses vapor refrigerant into a smaller space. So you can see at the right the tubing is larger than the tubing on the left. So you're taking vapor refrigerant and you're compressing it into a smaller space. And what that does is anytime you increase the pressure on something, you also increase the temperature. So when that vapor refrigerant comes out of the compressor, it's a high temperature, high pressure vapor, which you can see written there on the right hand side. So that vapor refrigerant makes its way down to the next part, which is your condenser. And no matter what system you have, whether it's an ice machine or an air conditioning system, as long as it's an air-cooled air conditioning system, you're going to have a fan blowing air across that condenser. And what that does is it condenses the vapor refrigerant into liquid. So at the top of that condenser you can see a bunch of water droplets. That's supposed to signify vapor refrigerant. And as that air blows over it, it cools it down and turns it back into a liquid. So it comes out of that condenser a high temperature, high pressure liquid, which you can see there at the bottom, and that liquid refrigerant travels to our metering device. Now in this case, the metering device I've got drawn on there, although it's a really crappy drawing, it's a TXV, or an expansion valve. So that liquid refrigerant gets to that expansion valve, and that metering device allows a certain amount of refrigerant to come through, number one, and number two, it goes from a smaller space to a larger space. And so what happens is as that refrigerant travels into that larger space, there's a pressure drop. And when we have a drop in pressure, we have a drop in temperature. So that liquid refrigerant now becomes a low temperature, low pressure liquid. And the reason why we do that, the reason why we drop the temperature, is because as we make our way up to our evaporator, we have to be able to pick up heat. Well, you can't pick up heat with hot refrigerant. That's why you need cold refrigerant. So we got to drop the temperature and the pressure. We got to drop the pressure so we can drop the temperature so that we can pick up heat in the evaporator section. So we get our liquid refrigerant up to our evaporator, and we blow air over that cold evaporator, and that air transfers its heat that's in that air into the refrigerant while it's in the evaporator. So as that refrigerant picks up that heat or absorbs that heat, it turns from liquid back to a vapor. And so it exits the evaporator as a low temperature, low pressure vapor. And that completes the cycle back to the compressor. So the compressor can only pump vapor. Some people will call a compressor a vapor pump. You might hear that term from time to time. It's because they can only pump vapor refrigerant. So again, compressor compresses refrigerant into a high temperature, high pressure vapor. The condenser rejects the heat that's in the refrigerant so that it can go from vapor to liquid, where it becomes a high temperature, high pressure liquid. The metering device drops the pressure. So whereas the compressor increases the pressure, the metering device lowers the pressure so that we have a low temperature, low pressure liquid, because whenever we lower pressure, we lower temperature. And then we go back into our evaporator where we pick up the heat and we turn our liquid refrigerant into vapor, making it a low temperature, low pressure vapor. So I hope that makes sense. I'm going to try and show you now in the real world what that looks like. So over here we have an ice machine. This is an ice machine. You got the internal parts there of your compressor and condenser area. And here is your evaporator. Behind this curtain, you have an evaporator. That's what an evaporator looks like on an ice machine. So with an ice machine on your evaporator section, you're not moving air over it because you're not trying to cool down the air. You're moving water over it because you're trying to cool that water down, remove the heat out of that water, and cause it to freeze to that plate to make ice cubes. So water comes out of here, flows down the plate. The plate has the refrigerant flowing through it on the back side. It absorbs the heat out of that water and causes it to freeze to that plate. So, getting back to this cycle right here, we're just going to start with the compressor. So, this is your compressor. Your compressor is compressing the refrigerant, vapor refrigerant, into a high pressure, high temperature vapor. And this is why it's important to know this stuff. Because when you're out in the field, this whole profession is about feeling, looking, and listening. So when you're out in the field, this is your discharge line, what they call your discharge line coming off the compressor. Okay, your discharge line will always, almost always anyway, be uninsulated. Your suction line, which is here, which is coming back from your evaporator, is always going to be insulated because it's cold, and we don't want it to freeze up, frost up, and have ice and condensation and moisture and water all over the inside of these machines. So they insulate them. So the compressor compresses your vapor refrigerant into a high temperature, high pressure vapor. It comes out of this discharge line, which is going to be the same as this right here. This is your discharge line coming off the compressor. So it comes out of this discharge line, it travels up, it's a little hard to see it. It's going to travel up, it's going to come over, it's going to go to the right here and go in to this condenser. This is the condenser on an ice machine. Now if we come around to the back side, you can get a better look. We'll take this air filter off. This is the condenser on an ice machine. Now they don't look too terribly different for air conditioning. The only difference is it's going to be outdoors, and it's going to be sitting on the ground, and it's going to be much larger because you got to cool down an entire house. But this is what the condenser looks like. And so what's happening is the refrigerant is starting up here at the top, right? Because if we come back over here and look at that line again, you can see it's entering the condenser up here at the top, right? That's because liquid is heavier than vapor, and it's going to naturally want to fall down. So as this fan motor right here, as this fan motor pulls air across this condenser, the liquid refrigerant that's in these lines here is going to cool down, because the air that's being blown across it is going to pick up the heat, absorb the heat from that refrigerant, and it's going to reject it. So as it comes down, the liquid refrigerant comes down, it's getting cooler and cooler and cooler. Midpoint is our saturation point, where we have both liquid and vapor existing inside our condenser. And as it makes its way further and further down, it becomes a liquid. By the time it exits out of this condenser, it's almost a full, in full liquid state. And at that point, we're in a high temperature, high pressure liquid, just like we show up here. So our condenser starts out as a vapor, refrigerant starts out as a vapor in our condenser, and as it makes its way through, and that fan begins to blow over it, it turns into liquid. And when it exits the condenser, it's a high temperature, high pressure liquid. So our refrigerant exits our condenser. It's a little hard to see. There's a little copper line down there. Oops. And I don't know if you guys can see it, but it's back there. It comes out of our condenser at the bottom and it travels, so that's it right there. Travels up, goes through this dryer here, and it travels up here, comes up, goes over, and then begins to travel that direction to the other side of the machine. So we got our liquid refrigerant traveling through here. It comes down through here, and meets our metering device. This is our metering device. So the refrigerant is entering here, going into our metering device. Our metering device drops the pressure. So as it exits our metering device, the pressure drops. And what happens with a pressure drop? We get a drop in temperature. So we come through the metering device and we go into our evaporator right here. So we go into our evaporator. The refrigerant enters down here someplace. And on the back of this evaporator plate, there's refrigeration lines that go back and forth and serpentine back and forth, just like it does on a on the condenser, but it's going the opposite direction. At least and in this case on an ice machine it is. And at some point, this doesn't matter. You don't really need to remember this, but at some point the refrigerant comes up and then starts making its way back down from the top side because they want to get an even freeze, and then exits somewhere right over here. So as our refrigerant travels through this ice machine, like I said before, water flows over it, and the refrigerant absorbs the heat out of that water. So over here, for air conditioning, you're blowing air over the evaporator, and the refrigerant is picking up the heat that's in that air, so that whatever air goes through it is colder. By the time it comes out, it's colder. And that's the air that goes through the ductwork in your house to make your house cold. So, when the refrigerant finishes traveling through that evaporator, it comes out here, it makes its way over here, comes back up. It's going through different tubing, by the way. They're just insulated together, but the tubing is separate. The tubing that fed it and the tubing that's being returned are two different tubes. Travels back over here, and then travels down this direction, and ultimately down here where it feeds back into the compressor. And so once it leaves that evaporator and begins traveling and making its way back into this compressor, we now have a low temperature, low pressure vapor, which is described here. We're leaving the evaporator as a vapor, low temperature, low pressure vapor, and we're going back into the compressor. Now, you can see there's a dotted line going down the middle here of this diagram. And that's because if you were to draw a straight line down, you would have half your system as a high side and half your system as a low side. So anything from this side over is your high side, anything from this side over is your low side. So your condenser, half your compressor and half of your metering device is the high side. And the evaporator, half the compressor, and the other half of the metering device is your low side. So I hope that helps explain both the drawing and correlating that to this machine here helps understand what exactly is going on with these systems. And like I said, it's really important to know this because when you're out working on something like this, you need to understand what's happening and why, so you can figure out how to fix the machine. If you get to a machine and your pressures are off, you're gonna have to start feeling around. So you're gonna come over here to your inlet on your condenser and you're gonna feel it. You're not gonna just come over here and just grab onto it like this. You're gonna kind of do this and feel it, because it's gonna be so hot that it's gonna burn your hand. So you're gonna touch it and just go, okay, yeah, that's really hot. And then what you're gonna do is you're gonna move down to where it's exiting down there at the bottom, right there. If it focuses a little bit, and you're gonna reach down here and you're gonna feel this. Now this side you can hold on to because it's already gone through the condenser and it's cold, or cool anyway. It's cool to the touch. It's not cold yet, but it's cool to the touch because it hasn't gone through the metering device. It's like room temperature. So you're gonna feel that. And that you should be able to hold on to that with no problem whatsoever. If you reach down here and you feel this and it's so hot you can't hold on to it, then you got a problem. And it could be that your condenser fan motor isn't running, which you're going to notice that right away. It could be that you've got a clogged air filter, and so you're not getting air across that condenser because the filter's clogged. How many times on air conditioning calls do you hear about clogged air filters? You know, that's one reason why we don't want clogged air filters, because if they are clogged, well, that wouldn't be the case on, I'm sorry, that wouldn't be the case on an air conditioning system, because your air filter is for your indoor air, not your outdoor air. But if you go to the outdoor unit and you see that this condenser is all clogged full of dirt and dog hair and it's got ivy growing all over it, then you know you've got your problem. It could be that. Because if you got it clogged full of junk, or you got plants crawling all over it, you're not going to be able to pull enough air across that condenser to cool that refrigerant down. If you can't cool the refrigerant down, you can't pick up heat in your evaporator. If you can't pick up heat in your evaporator, you can't cool your house down. So, but on an ice machine, you would have something like this. You'd come out and you'd look at this air filter, and it would be so dirty you could literally peel off. It'd be like peeling lint off of your dryer vent. You know, when you pull the screen out of your dryer and you take all the lint off, that's what it would look like. Because no one ever looks at this stuff. When you go into a restaurant and you look at an ice machine, no one's ever doing the maintenance. They're never pulling this off. This is just magnetized on there. It's not like it's difficult. They don't ever pull this off, this filter off, and rinse it off, and then stick it back on. They just forget it's there. And not because they're stupid. They're just busy with other stuff, running their restaurant. So, anyway, hope that helps going through and relating an actual machine with this diagram. If I had an air conditioning unit here, I would do it that way as well, but unfortunately, I don't. So anyway, just thought I'd put this together real quick. Memorize this and know it by heart. Know what each one of these parts does. Every system, refrigeration system, whether it's air conditioning, whether it's an ice machine, whatever it is, all have these four basic parts. They all have a compressor, a condenser, a metering device, and an evaporator. Know what those parts are by heart. Know what they do by heart. Know the state of the refrigerant as it goes from one to the other by heart. If you know that stuff and you can recite it off the top of your head, this stuff is going to be a piece of cake for you guys. It really is. This stuff is not rocket science. Like I said, it's all about listening to what's going on, feeling to make sure that the refrigerant's doing the right thing as it goes through the different parts, and of course, looking. So, I can't stress that enough. All right, I'll get off my soapbox. Have a good one.